So we have a test coming up, and that means it's time for some more review. This is assignment 25, the Algebra Basics Review Worksheet. Algebra Review Worksheet. And problem 1 says a to the 2/3 b to the 3/2 over a squared b, all raised to the 6th power. Many students like to apply this 6 to all these places. I like to simplify these first. Remember, when I'm dividing and the bases are the same, I can subtract the exponents. So 2/3 minus 2 is going to be a to the 2/3 minus 2 is going to be a to the -4/3, because that's 6/3. 2/3 minus 6/3 is -4. And then the same thing here. I'm dividing and the bases are the same, so 3/2 minus 1 is going to be b to the 1/2. But remember, b to the 3/2 minus 1. We have not only this, but we still have this to the 6th power. So now I'm going to apply that 6. Here I would have applied it 4 places and then had to simplify. I simplified first, and now I only have to apply that exponent to 2 places. Remember, when we raise a power to a power, we multiply. So -24/3 is -8. And when we raise a power to a power, we multiply. 1/2 times 6 is 3. It does not say anything about negative exponents, so this would be fine, but you're more than welcome to take it to here if you like. Okay? All right, problem number 2, something similar. 2 says 3x to the 2/3 over 3 to the 1/3 x to the -4/3. All right, well, actually here I'm going to apply this exponent to both of these places, and that's going to give me a to the 2/3, 3 to the 2/3 times x to the 2/3 over 3 to the 1/3 times x to the -4/3. And so I'm in that position again where I'm dividing and the bases are the same, so I'm going to subtract these exponents. 2/3 minus 1/3 is 1/3, and 2/3 minus a minus, right, because this says subtract this exponent. So 2/3 minus a -4/3 would be 6/3, or x to the 2nd. All right. 3. What's 3 say? We've got a to the 2/3, b to the -2, raised to the 3rd, raised to the -1. I'm going to start by multiplying those together. A to the 2/3, b to the -2, to the -3 power, and then I'm going to apply the -3 to each of these. So I'm going to have a to the -2 power, b to the 6th. Or, if you prefer, b to the 6th over a squared. Either of those is fine. How about number 4? Number 4 says cube root of 8x to the 5th, y to the 3rd, z. All right, so that says I got to get 3 of a kind. If I break these down, 5 of those, 3 of those, and that's to the 4th, 4 of those. Okay, so what can I do here? Well, since this is a cube root, I'm going to take out groups of 3. And so I can take out a 2, an x, a y, and a z. And then I have my cube root with what's left over. I see x times a z over here. And that's going to then be 2xyz cube root x squared z. All right, that's 4. 5 looks like rationalizing. 5, 3 plus square root of x over 3 minus square root of x. Why don't you do this one, if you haven't already, and come back when you're done and want to check your answer. That's right, I need to use the conjugate here. So 3 plus root x, 3 plus root x. When I FOIL on top, I get 9 plus 3 root x plus another 3 root x plus root x times root x is x. And then on the bottom, I have 9 minus 3 root x plus 3 root x. Root x times root x is x. Negative times positive is minus. All right, so let's tidy things up. These middle terms will cancel. 3 of them plus 3 of them gives me 6 of them. 9 plus 6 root x plus x over 9 minus x. Please, please, please don't cancel those or those. I say it in almost every video in this unit, and yet people still want to do that. Stop it. It's really not good. Okay, so there's number 5. How about 6? 6 says, hey, why don't you express the following as a polynomial in standard form? That means we're going to have to FOIL and distribute that negative in number 6. X plus 4, x plus 3, minus 2x minus 1, x minus 5. Okay, so FOILing will get me x squared plus 7x plus 12. Careful, don't lose that. When I FOIL here, I have 2x squared minus 10 minus 1 is minus 11x. Negative times negative is positive 5. But I've got to distribute this negative to each of these, and that's pretty much the most common mistake here. People forget to do that. So we've got negative 2x squared, minus times minus is plus 22x, minus times plus is minus 5. Okay, let's combine some like terms. Negative x squared plus 29x plus 7. And that's our polynomial in standard form. Standard form just means we're going to have descending powers of x. Okay? All right, so there's 6. Oh, 6a. 6b, a similar problem, except there's no FOILing to do first. Minus 4x minus 3x squared plus 2. Okay, why don't we start with distributing that negative? 4x squared minus 5x plus 1 minus 4x minus a minus is plus 3x squared. Minus times positive is minus 2. All right, so now combining like terms, 7x squared minus 9x minus 1. All done. All right, now on to 7. 7 says multiply or find the product. Okay, so 7 is 3a minus 2b, 3a plus 2b. And when I FOIL here, 9a squared plus 6ab minus 6ab minus negative 2 times positive 2 is 4, b times b is b squared. Since this is a difference of squares, it doesn't surprise me that the middle terms cancel, and I'm left with 9a squared minus 4b squared. That's their difference of squares. Remember, square root of this are these things. One of them gets a minus, and one of them gets a plus. Okay, 8. 8 says 3a minus 2b squared. And you know, that's not 9x squared minus 4b squared. It's not. That was this one. It has to look like this. This does not look like this. This, though, however, is 3a minus 2b times 3a minus 2b. Now I FOIL. I get 9a squared, and I get minus 6ab. And then I get minus 6ab, and minus times minus is plus 4b squared. When I combine these like terms, I'll have 9a squared minus 12ab plus 4b squared. There's our product. Okay. And then the last one, we've got 3a minus 2b to the third. So that's going to be 3a minus 2b times 3a minus 2b times 3a minus 2b. All right, why don't you try this one, see where it takes you, come back when you're done, or if you have questions. So, welcome back. When I've done this in previous videos, I had to FOIL some of them together first. So that's going to be 9a squared minus 6ab minus 6ab plus 4b squared times that 3a minus 2b. And, you know, I can combine like terms here. So I'll have 3a minus 2b times 9a squared minus 12ab plus 4b squared. All right, and now, remember when we talked about this in the multiplying polynomials video, we said, look, there are 2 terms here and 3 terms here. So 2 times 3 means when I'm done distributing this to each of these and this to each of these, I should have 6 terms before I combine like terms. I find it actually helps me catch small mistakes if I figure that out first. Okay, and then if I don't have 6 terms, when I'm all done, I know, oh, I missed something. 3a times 9a squared will be 27a to the third. 3a times negative 12ab will be negative 36a squared b. 3a times 4b squared will be 12ab squared. And now the negative 2. Negative 2b times 9a squared is going to be negative 18a squared b. And then here we have negative 2b times negative 12ab will be plus 24ab squared. And then negative 2b times positive 4 will be negative 8b to the third. Don't forget to combine these like terms. So we've got 27a to the third minus 54a squared b plus 36ab squared minus 8b to the third. Now, if you actually remember from Algebra 2 how to do this binomial expansion without having to do all the FOILing, by all means use that. That'll be fine. We'll be talking about that in the spring. All right, so that was number 9. 10 starts a section on factoring. So how can we factor this? U to the third, v to the fourth, minus u to the sixth, v. Well, you know, I think always, 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 you should try GCF factoring first. I can take out the smallest power. And what am I left with? Well, I took all of those, and I took one of those, so I have v to the third. Then we have our minus sign. We took out 3 of those, so we have 3 left over, and we took out that. Hey, look at that! It's a difference of cubes. See, they're cubes, and they're being subtracted. That's a difference of cubes. And so I can think about it as v being cubed minus u being cubed. And because I've memorized this pattern in which it factors, and really, you're not going to be able to do it if you don't, v minus u, this is this one squared, this is this one squared, and the middle term is this times this, change the sign. Don't forget though, that's only the factoring of v to the third minus u to the third. We have that GCF out front, so we need to make sure it shows up at the end. With difference or sum of cubes, this is never going to be factorable with real numbers, so you don't have to worry about it here. We're all done with number 10 there. Number 11, I see 4 terms. I see x squared minus 49y squared minus 14x plus 49. All right, so what are you thinking? Can you do GCF factoring here? I could take a 7 out of those, but not out of that. And I could take x's out of those, but not out of these. So, I think I'm just going to whimper a little bit. All right, I feel like I should be doing factoring by grouping here. But this problem actually reminds me of another one. It reminds me of this problem where I have to regroup them like that. And then here, this is x minus 7 times x minus 7. And then that's x minus 7 squared minus 49y squared, which, by the way, is x minus 7 squared minus 7y squared. And now we have a difference of squares. So it's x minus 7 minus 7y and x minus 7 plus 7y. So that's the way I think to do this problem. I know you are all thinking grouping in pairs. So I'm going to go do it that way now and see if we get the same answer. But rewriting it so that these three were together allowed me a perfect square trinomial which factors like that, and that set me up for difference of squares. I'm just worried that minus 7 minus 7y, x minus 7 plus 7y. Okay. I'm just worried that that won't work if I do that thing. Remember to grab that negative inside these parentheses. Is there anything I can take out here? No. I can take a negative 7 out of here, and I'm left with what? I'm left with 2x minus 7. And here, that doesn't do GCF factoring, but it does do x minus 7y, x plus 7y. Yeah. See? It doesn't get me anywhere. I don't have any like to factor out. I'm stuck. Let's try grouping them a different way. Let's try taking these x things together, x squared minus 14x minus 49y squared plus 49. I group those together, I can take out an x of x minus 14, and here I can take out a negative 49, and that gives me y squared minus 1. Well, that's a difference of squares, but I don't have anything that looks like that over here. So guess what? This was a tricky problem. If this were honors pre-cal, that would be a test question for us. But that idea of 4 terms not being factoring by grouping, but had to do that slide thing where I put 3 of them together, yeah, that's not something we're going to have to worry about on our test. It's good to think about. It's good to see, which is why it's here. But no, please don't get overly scared that you'll have to see those things on your own. Plus 9b to the 4th. All right, so anything we can factor out of all the terms? No. But look, that's a perfect square, and that's a perfect square. This is a perfect square trinomial. The square root of this is 4. The square root of this is 3. Is 4 times 3 times 2 that? Sure is. So I know this is going to factor as 4a squared plus 3b squared, 4a squared plus 3b squared. I could go the long way and say, okay, 6 times 9 is 144, and I'm looking for the factors of 144 that add up to 24. There would be 12 and 12. So I can use my regular factoring approach to this problem. From here, I can take out a 4a squared, and I'm left with 4a squared plus 3b squared. And here I can take out a 3b squared, leaving me with 4a squared plus 3b squared. And because these are the same, I can factor them out. And what am I left with? This and this. And there we go. Same answer. So if you see the pattern, great, that saves you some time. If you don't, you could still factor the trinomial. 13. 13 says 27x to the third minus 125. Will you please factor that? Okay, so hopefully you see that this is a difference of cubes. This is 3x being cubed minus 5 being cubed. Mr. Googla, how was I supposed to know that? Because you're supposed to know, for example, that 3 to the 1 is 3, and 3 to the 2 is 9, and 3 to the third is 27, and 5 to the 1 is 5, and 5 squared is 25, and 5 to the third is 125. We talked about this in our first video for the Algebra Basics unit, and just because it was a while ago doesn't mean that you're not supposed to recognize these numbers as cubes. You are. Okay, so look, it's a difference of cubes, and again I'm going to say you're not going to be able to do this on the test if you don't take the time to actually memorize the pattern. So I'm taking the cube root of this and the cube root of this and putting them in here with the same sign. This position is this one squared. This position is this one squared. And the middle term is this times this, change the sign. Okay, there's problem 13. How could you check to see if you've done it properly? Multiply it out. This times each of those, this times each of those, and combine like terms. You should end up here. All right, 14. We've got x to the fourth minus 8x to the third plus 16x squared. All right, give it a try. Come back when you're done factoring this trinomial. There are a lot of students who do this one by just trying to leap into this. But I really want to encourage you, always think about doing GCF factoring first. Look, they all have x's. I can take x to the second out of all of them. And now I have this perfect square trinomial, x minus 4, x minus 4, and don't forget the x squared out in front. All right, that's problem 14. 15, we've got 2x squared minus 4x minus 8. Hey, look, I can take a 2 out of all of those. Uh-oh. Well, the factors of negative 4 are negative 2 and 2, negative 1 and 4, and negative 4 and 1. Do any of these add up to negative 2? No. So that's all I can do, is just the GCF factor in there. Okay, now 16 has a starting solving. Ooh, and look, one rational equation equals another rational equation. 6x plus 11 over 10x minus 3. So if we multiply both sides by the least common denominator, and we're going to do that over here as well, 5x plus 7 and 10x minus 3. These will cancel, these will cancel. So I'm going to be left with 10x minus 3 times 3x plus 1 equals 6x plus 11 times 5x plus 7. Now, this is the same as if we had done cross multiplying, which you may recall from Algebra 1 or middle school. Okay, let's FOIL here now. We've got 30x squared minus 9x plus 10x minus 3. And here we have 30x squared plus 55x plus 42x plus 77. Combining like terms, I have 30x squared plus 1x minus 3. And here I have 30x squared plus 97x plus 77. Now if I subtract 30x squared from both sides, my x squareds go away. So this becomes a linear equation, and that means I want the x's on one side and the numbers on the other. I'm going to subtract 77, I'm going to subtract x, and so what's that going to give me? Well, let's jump to the top of the board and see that we're going to have negative 80 equals 96x. And if we divide both sides by 96, we get negative 16. I can divide each of these by 16, so it's negative 5/6 equals x. All right. Oh, did you forget that this is a must check because there's algebra stuff in the denominator? Don't forget your must checks. No one's going to remind you on the test. So when I look at this original problem, 5x plus 7 equals 6x plus 11 over 10x plus 3. What turns these into 0? Well, that would be negative 7/5, and that would be 3/10. Is this either of those? No. No, it's not. So our answer is okay, but it won't always be, so please make sure you are checking must checks. 17, x squared minus 6x equals negative 8. Please don't do this. Because that's not right. That's, I mean, just so wrong. Here, no, not even gonna. This is not okay. This is not good. Don't do that. When you have a quadratic, you have to move everything onto one side so that this is equal to 0. We need to see x squared minus 6x plus 8 equals 0. Now I want to factor. Now I want to factor this as x minus 2, x minus 4, and now I'm going to set those factors equal to 0. And I'm going to get x equals 2 and x equals 4. Okay? Please, when it's greater than first degree, move everything onto one side and factor. But don't factor before you move everything onto one side. Okay, 18. 20x to the third plus 8x squared minus 35x minus 14 equals 0. Well, I don't see a GCF, but I do see 4 terms, so I'm thinking about factoring by grouping here. I can take out a 4x squared, leaving me 5x plus 2. I can take out a negative 7 here, leaving me 5x plus 2. Because these two terms have 5x plus 2 in common, I can factor out a 5x plus 2. And what am I left with? This, 4x squared, and this, minus 7. Okay, now what are we supposed to do? Well, we're supposed to set each factor equal to 0. So that becomes that or that. And this and when I take the square root of both sides, what am I not supposed to forget? I'm not supposed to forget that plus or minus. The reason I split this up is because the square root of 4 is 2. And so it can be a little less radically. I'm not particularly fond of radical of fraction. Okay? So we've got 1, 2, 3 solutions to problem number 18. All right, we're halfway through, almost. No, 20 is halfway through. So let's take a look at 19. We've got 2/3 x minus 1 plus 1/4 x equals 10. I mean, you're welcome to distribute and combine like terms, but I want to take the common denominator of 12 and multiply it by each term to clear out all the fractions, because when I do here, I end up with 4 times 2 times x minus 1, and here I have 3 times 1x, and here I have 10 times 12. So I'm going to have 8x minus 8 plus 3x equals 120. That's going to be 11x minus 8 equals 120. 11x equals 128. And divide both sides by 11. Now, I know 11 times 11 is 121, and so that's not like 11 doesn't go into that evenly. So rather than write this as 11 and 7/11ths, that mixed number, I'm just going to leave it as this fraction. Okay. 20. 20 says x minus 2 over x plus 2 plus 4 over x plus 2 plus 4 equals 0. And here, I've got a common denominator already for some of the terms. So I'm going to multiply all of the terms by that, because then these will cancel and these will cancel. I have x minus 2 plus 4 plus 4x plus 2 equals 0. I can combine some like terms here. I need to distribute here. And so I get 5x plus 10 equals 0. 5x equals negative 10. X equals negative 2. Now, what do you need to do? That's right. Algebra stuff in a denominator. This is a must check. What happens when you plug negative 2 in there? Negative 2 plus 2 is, that's right, 0. So we can't have 0, so there's no solution here. No solution. All right. 21. I've got 2 root x minus root 2x plus 1 equals 1. So here, I need to isolate a radical so that I can square both sides. I can't square each piece. That's pool noodle. So I think what we're going to do is take this one and move it over here. I'm going to take this and move it over here. And the reason I want to do that is because there's less stuff than if I moved this over here and left the 1 there. I'm moving this also because I don't want a negative in front of it. I want a positive. Okay, so it's at this point where we can square both sides. So here, squaring the square root leaves me 2x plus 1. But what about over here? So this is 2 root x minus 1 times 2 root x minus 1. I FOIL. 2 times 2 is 4. Root x times root x is root x squared, which is x. Then this times that is minus 2 root x. And this times that is minus 2 root x. And then negative 1 times negative 1 is plus 1. Okay, so we've got 4x minus 4 root x plus 1 equals 2x plus 1. Again, I want to isolate that radical because I need to square both sides again. So I'm going to subtract 1 from both sides. I'm going to subtract 4x from both sides. It's going to give me negative 4 root x equals negative 2x. I'm going to divide now by negative 4. And so I'm going to end up with root x equals 1/2 x. And how do I get rid of that? I square both sides of the equation. Now I've got x equals 1/2 times 1/2 is not 1, it's 1/4 x squared. Because of this, I want to move everything onto one side of the equation and get 0 equals 1/4 x squared minus x. And now I notice I could factor in x out of each of those. 1/4 x minus 1. Remember, x divided by x is not 0, it's 1. If I set each of my factors equal to 0, I'm going to get x equals 0, or 1/4 x equals 1. If I multiply both sides, I get x equals 4. Now, is this a must check? Yes. When I square both sides of the equation, which I did twice in this problem, that's a must check. So let's go back to our original and plug 0 in. If I plug 0 in here, I get square root of 1, which is 1. 0 in here, I get 0 times 2 is 0, and I had minus 1. Well, minus 1 doesn't equal plus 1, so that's garbage. What about 4? Square root of 4 is 2, times 2 is 4, minus 2 times 4 is 8 plus 1 is 9, square root of 9 is 3. And that is true. So that's my only solution. That is not a solution, and I won't catch that if I don't remember my 3 must checks. Okay, so where are we now? 22. 22 says x minus 6 root x plus 8 equals 0. And, you know, in my brain, this is the same as this problem, which I think we did earlier in this video. That's going to be x minus 2, x minus 4, right? It's the same coefficients and the same pattern of signs, and this power is half of that. Well, this is x to the 1/2, and this is x. This power is 1/2 of that. And so my factored form will be root x minus 2, root x minus 4, and then I have to set each of these factors equal to 0. I get root x equals 2 and root x equals 4. I square both sides to get x equals 2 and x equals, I don't know why I said 2 because I knew it was 4, and x equals 16. Okay, but since I squared both sides, this is a must check. So let's go back and must check. Square root of 4 is 2. 2 times 6 is 12, so I have minus 12 here. I have 4 plus 8 is 12, minus 12, that does equal 0, that one's good. If I plug in a 16, square root of 16 is 4, times negative 6 is negative 24. And here I plugged in my 16, and I have my plus 8. 24 minus 24 is 0. That one works as well. All right, 23. 23. Let's take a look at u. Square root 7x plus 2 plus x equals 6. Remember, we don't square each piece. We have to isolate the square root before squaring both sides. You know, it's kind of like with absolute value equations, where we have to isolate the absolute value before we write the positive and negative components. So I'm going to have root 7x plus 2 equals 6 minus x. And now that I've isolated the radical, I'm ready to square both sides. And so I'm left then with what? Well, squaring undoes the square root. But over here I have to FOIL. I have to do 6 minus x times 6 minus x. We've got 7x plus 2 equals 36 minus 12x plus x squared. I'm going to move everything onto one side so I can factor. 0 equals 34 minus 19x plus x squared. And that is something that's often hard for people to factor, so I'm going to put it in descending order, because that'll be easier on the brain. And then I'm going to say, oh, no problem, x minus 17, x minus 2. And so what are my solutions? X equals 2, x equals 17. However, remember, this is a must check, because we squared both sides. So if I take that 2 and plug it in here, 2 times 7 is 14. 14 plus 2 is 16. The square root of 16 is 4. 4 plus 2 is 6. That one works. How about 17? Well, 17 times 7, is that 139? 17 times 7, 4, 119. Plus 2 is 121. And the square root of 121 is 11 plus 17 Does that equal 6? 28 doesn't equal 6. Oh no. Oh no. So I don't believe I have two solutions here. I think I just have the one. That's 11 plus 17, 28 does not equal to 6. So that's garbage. I'm going to get one solution. And you know, if I think about this graphically, if I back it up to here, I've got my square root shifted a little bit over, -2/7. And I have this line with a y-intercept of 6 and an x-intercept of 6. Looks like this. How many points of intersection? Yeah, only one. Okay. What's next? 24. 24 square root 3x plus 1 minus square root x plus 4 equals 1. You should give this one a try now. See if you're comfortable doing this. Pause the video, come back when you're done. Okay, welcome back. So, remember, we can't square each side until we isolate our radical. So I'm going to add this to both sides. 3x plus 1 equals 1 plus root x plus 4. And now I can square both sides, but be careful. Again, it's not square each piece, it's square the whole side. So there's going to be foiling over here. On the left-hand side, I've got 3x plus 1, because when I square that square root, they cancel, leaving me just the radicand. Here, however, 1 plus root x plus 4, 1 plus root x plus 4. And now I've got my foiling to do. So I'm going to add 1 plus 2 root x plus 4s plus this one times this one is just going to be x plus 4. 3x plus 1. Okay, so I need now, because I still have a square root, to move everything that's not that square root over here. So 3x minus 1x is 2x. Subtract 1 from both sides, those go away, and I subtract 4 equals 2 root x plus 4. And I think I'm going to prefer to divide everywhere by 2. So I've got x minus 2 equals square root of x plus 4. And square both sides. And what should I be thinking about now? That's right, I need to think about, oh my goodness, I squared both sides. Let's not forget to must check this one. Going to subtract x, going to subtract 4. And now I can factor. And I get x equals 0 and x equals 5. Well, let's try them out. If I plug a 0 in here, square root of 1 is 1. If I plug a 0 in here, I have the square root of 4, which is 2. 1 minus 2 is negative 1, not positive 1. So that doesn't work. How about 5? 3 times 5 is 15, plus 1 is 16. The square root of 16 is 4. And 5 plus 4 is 9. Square root of 9 is 3. 4 minus 3 is, in fact, 1. So we have a solution, only x equals 5. Only one solution, though. You've got to check the must checks. You really have to pay attention to that. All right, let's look at some absolute value equations now. I've got absolute value of 3x minus 1 equals negative 7. Yeah. 3x minus 1 equals negative 7. There's the positive component. 3x minus 1 equals positive 7. So I have 3x equals 8, or x equals 8 thirds. I have 3x, sorry, no, that's a negative 7 plus 1 is a negative 6. Negative 6 divided by 3 is negative 2. All right, here I get 8. And I get x equals 8 thirds. So, are we done? Yeah, no. See, because here's what I notice. There's my absolute value graph shifted right 1/3. This is the horizontal line y equals -7. When does the absolute value intersect the line y equals -7? Yeah, it doesn't, ever. So that can't work, and that can't work. This is no solution. Well, if I'm not thinking about this graphically, and I really wish you would think about these things graphically, let's see what happens when we plug in our numbers. -2 times 3 is -6, and -6 minus 1 is -7, and the absolute value of -7 is not -7. And over here, if I put in 8/3, 8/3 times 3, the 3's cancel out. I have 8 minus 1, which is 7. The absolute value of 7 is 7, not -7. So neither of those work. And what we said back in when we were doing the solving video is if you ever have an absolute value equal to a negative, that's going to be no solution, because remember, the absolute value only poops out positives. You know, if I plug in a -2, I'm getting +2, right? Absolute value only poops out positive things. So this absolute value will never be able to poop out a -7. All right, 26. 26 says absolute 4x minus 1 equals 7. Why don't you do this one? Okay, welcome back. Did you write the positive component, 4x minus 1 equals 7, and 4x minus 1 equals -7? Great. So we've got 4x equals 8, and x equals 2. Or here, 4x equals -6, and x equals -3/2. Now, let's think about this graphically. Here's my absolute value graph shifted over 1/4. And we have the line y equals 7. Oh, look, 2 points of intersection. Yes, I like that. Okay. Remember, if you have questions on this stuff, please send them to the GroupMe or ask them in our synchronous Zooms. So where are we now? We're at 27. This is 2 absolute 2x plus 1 equals 19. Remember, we can't write the positive and negative components until after we isolate the absolute value first. We have to do that first. So I'm going to subtract 1 from each side. I'm going to divide by 2. And now I can write the positive and negative components. When the absolute value is all by itself, when we've isolated the absolute value, we can write 2x plus 1 equals 9, and 2x plus 1 equals -9. So I'm going to get 2x equals 8, or x equals 4, and I'm going to get 2x equals -10, or x equals -5. You know, I don't have absolute value equal to a negative or absolute value equal to algebra stuff, so I feel pretty confident about these, but on a test I'd probably plug these back in. Okay, that's 27. How about 28? 28 is an inequality. 6 over 10x plus 3 less than 0. Well, great. Let's remember what we're supposed to do with inequalities. First, turn that into an equal sign. Then, because we have a fraction, let's multiply both sides to get 6 equals 0. Oh, well, there's no solution to that. Is that the only place we get critical numbers from solving the equation? No, remember, the denominator provides us a critical number as well. -3/10. So put -3/10 on my number line, and I'm going to try something on either side. If I plug in a 0, I end up with 6 divided by 3, which is 2. Is 2 less than 0? No. How about -1? -1 times 10 is -10 plus 3 is -7. 6 divided by -7. Is that less than 0? Yes. And this point can never be included. Even if this were this, I wouldn't be including this point. Remember, because this came from a denominator, and those will never be included. So, can I write my solution? Sure can. Don't use your test point, use your critical point. Negative infinity to negative 3/10 with parentheses. There's our answer to 28. Okay, 29. 2 absolute 3 minus x plus 1 greater than 5. Okay, do it. Show me. Come up with this. What's the solution going to be here? You should know, just based on this video, things that we're supposed to be doing. So give it a try now. Even if you've done it before, try it again now. Come back when you're done. Okay, so because it's an inequality, the first thing I do is turn that inequality into an equal sign. I subtract 1, I divide by 2, and now is the perfect time for me, now that I've isolated the absolute value, it's the perfect time for me to write the positive component and the negative component. Okay? So if I subtract 3 from both sides, negative x equals negative 1. So x equals 1. And if I subtract 3 from both sides here, I have negative x equals negative 5, or x equals 5. Okay, so these are not my solutions. These are merely my critical numbers, 1 and 5, because I have an inequality. I need to test those intervals. Okay, if I plug in a 0, absolute value of 3 is 3. 3 plus 2, 3 times 2 is 6, plus 1 is 7. 7 is greater than 5. Nice. If I plug in a 2, 3 minus 2 is 1. Absolute value of 1 is 1, times 2 is 2, plus 1 is 3, and 3 is not bigger than 5. And if I plug in a 10, 3 minus 10 is negative 7. The absolute value of negative 7 is 7. 7 times 2 is 14, plus 1 is 15, and that sure is bigger than 5. And the points themselves, well, if I plug in a 1 here, 3 minus 1 is 2, times 2 is 4, plus 1 is 5. Is 5 bigger than 5? No. And that's going to happen here as well. So my solution should be negative infinity to 1 union 5 to infinity. Remember, don't put your test points here. Don't use these points here and here. Use your critical numbers. Okay? Excellent. There's 29. How about 30? 30 says absolute value of 16 minus 3x less than or equal to 5. So, get rid of that inequality. Write your positive and negative components. And I'm going to subtract 16 from both sides. And so I get x equals 11 over 3. And here I'm going to subtract 16 from both sides. And I'm going to get x equals 7. All right, these are not solutions, they're critical numbers, 11 thirds and 7. So this is almost 4. So how about I put in a 5 and a 10. And let's check, let's test these intervals in our original inequality. If I plug a 0, that's going to go away. I'm going to have absolute value of 16, which is 16. Is 16 less than or equal to 5? No. If I plug in a 5, 3 times 5 is 15. 16 minus 15 is 1. The absolute value of 1 is 1, and that is less than 5. And if we plug in a 10, 16 minus 30 is negative 14. The absolute value of negative 14 is 14, which is not less than 5. Because I could be equal to, that's going to be a yes, and that's going to be a yes. And if you don't believe me, plug those numbers in. 3 times 11 thirds is going to be 11. 16 minus 11 is 5. The absolute value of 5 is 5. Is 5 less than or equal to 5? Yes, it is. So it's going to work. So my solution, bracket, 11 thirds, comma, 7, bracket. All right, last 10 problems. 31. 31 says x squared 3 minus x over x plus 2 less than or equal to 0. Well, we know the first thing we need to do is turn that into an equal sign. If I multiply both sides by x plus 2, I get x squared 3 minus x equals 0. Hey, look, these are already factored. So it's x squared equals 0, or when I take the square root of each side, I get x equals 0, and 3 minus x equals 0, so x equals 3. Are these my only critical numbers? No. The denominator also provides a critical number. So x plus 2 equals 0, or x equals negative 2. So we've got three critical numbers, negative 2, 0, and 3. And we want to test these intervals. Okay, let's test these intervals in the original inequality. 4 intervals to test. So 3 minus 4 is negative. 4 squared is positive. 4 plus 2 is positive. So I have a positive times a negative, which is negative, divided by a positive, which is negative. Is a negative less than or equal to 0? Yes. If I plug in a 1, 3 minus 1 is 2. That's a positive times a positive, divided by a positive. This is going to turn out to be a positive when I plug in 1. Is that less than or equal to 0? No. If I plug in a negative 1, 3 minus a minus 1 is 4. That's positive. Negative 1 squared is positive, so positive times positive. X negative 1 plus 2, that's positive. So I've got positive over positive. Is that less than or equal to 0? No, positive numbers are not less than or equal to 0. And if we plug in a negative 3, 3 minus a minus 3 is 6, that's positive. Negative 3 squared is positive. Negative 3 plus 2 is negative 1, that's negative. So positive times positive divided by negative is going to be negative, and a negative is less than or equal to 0. So that's a yes. Remember also that the critical points here, because this is or equals to, this is a yes, and this is a yes, but this one from the denominator, any critical number from the denominator is always going to be a no. So what's my solution look like here? Well, we've got yes here, so we've got negative infinity up to negative 2 with a no. And then we're going from 0, which is a yes. Oh, huh? That's interesting. Kind of want to go back and check that, because that's just a point. Union x equals 0, union 3 to 4. Oh, 3 to infinity. So let's check this again. And this time I'll actually plug these values in. 1 squared, 3 minus 1 over 1 plus 2. Is that less than or equal to 0? So that's going to be 2 times 1, which is 2 thirds. Is that less than or equal to 0? No. Okay. And what about negative 1? Okay, so negative 1 squared times 3 minus a negative 1 over negative 1 plus 2. That's 1 times 4 over 1, and that's positive 4. Is that less than 0? No. Well, then let's test 0. 0. 0. I said 0 was a yes, does 0 work? 0 squared, 3 minus 0 over 0 plus 2. Is that less than or equal to 0? That's 0 times 3 over 2, which is 0 over 2, which is 0, and that is less than or equal to. Ew. So, what a strange thing. Ew. Yeah, don't freak out about it. I won't be doing that to you. Okay, 32. 32. We've got x to the third greater than x squared. So if that's x to the third equals x squared, I know that I need to subtract x squared from both sides, so this can be equal to 0. And then I'm going to factor out an x squared. Remember, x squared divided by x squared is not 0, it's 1. So x squared equals 0, x minus 1 equals 0. Take the square root of both sides, add 1 to both sides, you get two critical numbers, and 3 intervals to test. So 2, 1/2, -1. Okay, we're testing back up here. -1 to the third is -1. Is that bigger than -1 squared, which is 1? -1 is not bigger than 1, so that's a no. What about 1/2? 1/2 to the third is 1/2 times 1/2 times 1/2, or 1/8. Is that bigger than 1/2 squared? Well, 1/2 times 1/2 is 1/4. Is 1/8 bigger than 1/4? If you have an eighth of a pizza, are you getting more than a quarter of a pizza? No, you're not. And if we plug in 0, 0 is not bigger than 0, that's a no. How about if we plug in 1? 1 is not bigger than 1, that's a no. And finally, I'm going to plug in 2. 2 to the third is 8, 2 squared is 4, 8 is bigger than 4, and so that's a yes. So my solution will be from 1 to infinity only. Okay, 33. 33 says x plus 2 over x equals x minus 1 over x minus 4x plus 2 over x minus 3. Well, I see x stuck in the denominator, so I know this is a must check. I also want to get rid of all these denominators, so I'm going to multiply by the least common denominator, x plus 3, x minus 3, and x minus 3. And here, x minus 3. So what happens? Well, I see that these are going to cancel, and I'll be left with x minus 3 times x plus 2. And then over here, this cancels that. I'm going to have x minus 1 times x minus 3. I'm going to have this minus sign. This canceled all of that, leaving me 4x plus 2. Be careful. This minus has to go not only here, but to here. Okay, so I've got x squared minus x minus 6 equals x squared minus 4x plus 3 minus 4x minus 2. If I subtract x squared from both sides, they go away. I combine like terms over here. And now because this is linear, right, I don't see any powers bigger than 1. I want to get the x's on one side and the numbers on the other. So adding 8x, adding 6, and I get 7x equals 7, or x equals 1. All right, now this is an equation, and I've solved the equation, and I've got x equals 1. Does that work? Sure. 3 would turn that into 0. 0 would turn those into zeros. This is neither 3 nor 0, and so that's my answer to this problem. It was not an inequality. If it were an inequality, this would be a critical number, 0 would be a critical number, 3 would be a critical number, and I put them all on the number line in test regions. But that was an equation, not an inequality, so we don't have to worry about it. Okay, we've got two GCF factoring problems. 4x plus 1 to the third, 3x minus 2 plus 3x minus 2 squared times 3 times, oh my god, these are so long, 4x plus 1 squared times 4. All right, so I can take 4x plus 1 to the second out, and I can take a 3x minus 2 to the first out. Now, I see here 2 times 3 is 6, I see 3, I see 4, that's going to be 12, so I can pull out a 6 as well. All right, what's left over? I took out the 2 and the 3 for that 6. I took out the 3x minus 2, and I took out 2 of these 3, so I still have a 4x plus 1. Now we come to our plus sign, and over here, I took out the 3, and I took out 2, right, because I took out 6 from that 12, so I still have a 2. I took out the 4x plus 1 squared, that's gone, but I only took out one of these 3x minus 2's. So we still have a 3x minus 2. Okay, so this is going to be 6, 4x plus 1 squared, 3x minus 2 times 4x plus 1 plus 6x minus 4. And that's going to be 10x minus 3 times 3x minus 2 times 4x plus 1 squared times 6. Remember in here, when you're done combining like terms, please take a second look and make sure there's nothing else to factor there. All right, what about our other GCF factoring problem? 1/2 4x plus 1 to the negative 1/2 times 4 times 3x minus 2 to the 2/3 plus 3x minus 2 to the negative 1/3 times 2/3 times 4x plus 1 to the 1/2 times, at the very end, a 3. All right, we still only have two terms. What do they have in common? Well, I see a 3x minus 2 and a 3x minus 2, so I take out the smaller power. And I see a 4x plus 1 and a 4x plus 1, and I take out the smaller power. And I could take a 2 out of each of these. Yeah, I'm going to take a 2 out as well. So what am I left with? Well, I took out a 2, so I still have this 1/2 and that errant 2. I took out the 4x plus 1 to the minus 1/2, but I took out from here 3x minus 2 to the negative 1/3, so I factored a negative 1/3. Well, that's going to be plus 1/3, or 3/3, which is 1, so 3x minus 2 to the first. Now we have our plus sign. We took out the 3x minus 2 to the negative 1/3. We took out the 2, so we still have a 1/3 here. And we took out the 4x plus 1 up to the negative 1/2. We factored a negative 1/2. So that's going to give me 4x plus 1 to the first, and then I still have that 3. Hey, look at that. 1/3 times 3, those are going to cancel. 1/2 times 2, those are going to cancel. So I'm just left with 3x minus 2 plus 4x plus 1 inside there. When I combine like terms, that's 7x minus 1 times 2 times 4x plus 1 to the negative 1/2 and 3x minus 2 to the negative 1/3. You can certainly move these to the bottom and make them positive if you want, but look, if you do that, then you've got a square root in a denominator, and a lot of really old people say you can't have radicals in the denominator, so I'm just going to leave it where it is right now. All right, that was the last of our factoring. 36 says evaluate without a calculator, 27, 3 over 2 to the negative 2. Okay, so if I apply that exponent to each of these, I have 27, 3 to the minus 2, 2 to the minus 2. It's going to be 27 times 2 squared over 3 squared. That's going to be 4 over 9. Oh, 4 times 3, or 12. I didn't need a calculator for that. 37, 64 to the 2/3 power. Well, we talked about these a couple of times in this unit, and we said that when I have a problem like this, where I want to reach for the calculator, instead try rewriting the base. Because then when I raise a power to a power, I'm going to multiply and cancel those 3's, and get 4 squared, or 16. 38, 4.2 times 10 to the 8th, and 3 times 10 to the 3rd. So we don't do much with scientific notation in our class. That's about it. But scientific not only shows up in science classes, it also shows up on the ACT and the SAT. So I just wanted to make sure you were still thinking about this. When I'm dividing and the bases are the same, I can subtract the exponents. And what about here? 4.2 divided by 3. Well, it turns out that 3 goes into this 1.4 times, because 3 times 14 is 42. And there's my answer for 38. Okay, 39 says rationalize the denominator. All right, do you see 1, 4? And so you're going to rationalize with 2 more 4s? Yes, you can. And so you get 3 cube root of 16 over 4. But if you stop here, I mark it wrong because you can still simplify that. 3 cube root 2 times 2 times 2 times 2. See, we can pull out a 2. So this is going to be 3 times 2 cube root. Who's left inside? Only 2 over 4. This can cancel here. And so my answer should be 3 cube root of 2 over 2. Now, that is a fine way to do the problem. It's not the way I do the problem, as I've said before. As I said, 3 cube root of 4, I see 2 2's here. So I need to multiply by 1 more 2. So I'm going to have 3 cube root of 2, 2 times 2 times 2, I can pull out a 2. And look, I get the same answer, and I don't have to worry about simplifying when I thought I was done. Okay, last problem, 40, 6 over 1 minus root 3. This is a binomial with a radical, so I need the conjugate. On the bottom, I'm going to FOIL. On the top, I'm actually going to resist the temptation to distribute, and I'll show you why in a moment. On the bottom, I have 1 minus root 3 plus root 3. Root 3 times root 3 is root 9. Square root of 9 is 3. Negative times positive is negative 3. Okay, so let's combine like terms. These go away. 1 minus 3 is negative 2. 6, 1 plus root 3. So remember how I said I was going to resist the temptation to distribute? Yeah, and here's why. Because I'm more likely to see this canceling. 3, 1 plus root 3 over negative 1. You know, and I would probably write that as negative 3, 1 plus root 3. Yeah, you could certainly distribute if you want, but I'd probably leave it there. So here's the deal. If I distribute, then I've got, there's our answer, so let's erase over here. Then I've got 6 plus 6 root 3 all over negative 2. And some people, when it's in this form, say, oh, I could take a negative 2 out of everything. But some people only do that. Or some people don't even think they can simplify it. So the way to avoid that kind of trauma is just resist the temptation to distribute there and see if instead there's some canceling that can be done with those. And there was. All right, so I hope you're starting to feel ready. Remember, it's on you to actually study for tests. And you know, you've got, well, you should have notes from all the videos you watched. You should have watched all the videos. You've got all those homework assignments to practice. Here is an algebra basics review worksheet that you should be comfortable with. And there's a set of stations there as well. So come on, step up. You can do this. And look, saying, but I don't know how to do this stuff, that's not okay. That's actually, from a guy who failed math twice in high school, that's you being lazy. Because if you don't understand and we're the day before the test, guess what? You need to come in. I mean, you need to get on the group meet. You need to get on the Zoom. You need to start asking questions. And you need to start taking some ownership for this. So please take some ownership for this. It's the only way you're going to be able to get through. All right, take care, everyone.